Welcome everybody. So today we are going to talk about naming for covalent compounds. So far we've done ionic compounds. Today we're going to do covalent compounds. And inevitably some people get confused because they look at a compound and they don't know if it's ionic or covalent. So remember, with covalent compounds you have only nonmetals. So that's what you're looking for, only nonmetals. And something that's important about this is be careful, because you could have a compound like SO3 versus SO3 2-. And you might look at this and be like, alright, well, what's the difference? They're both covalent. Well, they both have nonmetals. But this one would fall under the covalent rule naming, and this one would fall under the ionic naming, where you would call it sulfite, the ion. We'll actually come back and name SO3 without the charge, but you have to be careful. If it's an ion, it's part of an ionic compound, use the ionic names. So for example, SO3 2- would probably fall under like Na2SO3, for example. Now, how do I do this? How do I name covalent compounds? Well, we're going to do name to formula first. So let's say I gave you a name that you probably know, carbon dioxide. So first you write the symbol for the first element, carbon, so that's C. Then you write the symbol for the second element, O. Then you use the prefixes as the subscripts. Since it's dioxide, it's 2 oxygens, and those 2 oxygens, you would show di for 2 oxygens, it would be CO2. Notice I don't have this monocarbon dioxide, and that's because mono, it's used for ide only. So let's try another one. Let's try something like dihydrogen sulfide. And this would actually probably be dihydrogen monosulfide. So dihydrogen, we'd have H for hydrogen. Sulfide, we'd have S. And now dihydrogen, we'd have 2 H's and 1 S. Mono is 1 S. So this is our, naming for name to formula. Here are the prefixes: mono, di, tri, tetra, penta, hexa, hepta, and octa. I go up to 8. Now what if we have formula to name? Well, let's take the example that I wrote up here before, SO3. So the name of the first element, we put a prefix in front of it only if it has more than 1 element. This only has 1, so this is just going to be sulfur. And then O is oxide, and now we need the prefix. So the prefix for this would be sulfur, and then we would have the prefix, so the prefix would be trioxide. So this would be sulfur trioxide. Well, notice I don't have monosulfur trioxide. Mono's only used for the ide. Let's say I had something like this, N2O5. So this would be dinitrogen, and then we would have after that pentoxide. So here we have dinitrogen pentoxide. So dinitrogen, nitrogen, O, oxide, 2, dinitrogen, 5, pentoxide. Notice a little nuance here. I drop the A from penta when I have 2 vowels next to it. So it's not pentaoxide, it's pentoxide. You see that with monoxide, it's not monooxide, it's monoxide. Okay, so we'll do lots of practice with these, but this is the general idea. You have to memorize the prefixes, and you have to recognize when something is covalent so that you don't call ionic things with prefixes. Like, you're never going to have like disodium or, dipotassium tetrasulfate. We don't do that. We use the charges, and then it's understood. Okay, so the next thing I want to talk to you about is naming acids. So with an acid, all that we're doing is we're taking an ionic compound like Na3PO4, and we're replacing the metal ion, the sodium, and we're replacing it with a hydrogen ion, H+. So something like sodium phosphate, sodium's +1, hydrogen is +1. So the hydrogen, you would need 3 of them to replace the 3 sodiums. You would have H3PO4. We call this phosphoric acid. Now, how do I know how to name this? Well, I'm going to rewrite this chart here. I like it a little bit differently organized, but this chart goes through how to change the naming. If you start out with the 8 form of the ion, then you become an ic acid. If you have the per 8 form of an anion, it becomes per ic acid. If you have the ite form of an ion, it becomes us acid. And if you have the hypoite form, it becomes hypo-us acid. And finally, if you have the ide form of an ion, it would become hydroic acid. So what does this look like? Well, when I look at this, let's say I were to do something like HiO4, HiO3, HiO2, HiO, and then HI. So all of these are using iodate. So HiO3, if we change the color here to show this, HiO3, 8 becomes ic. So this would be iodic acid. Per 8 becomes per ic, so this would be per iodic acid. Ite becomes us acid, so this would be iodous acid. Hypoite becomes hypo-us, so this becomes hypo-iodous acid. And HI becomes hydroic, so this would be hydroiodic acid. So you have to be able to go both ways. You have to be able to say, I can go from the name to the formula to the name. So for example, we could do a problem where we have like H2CrO3. So first thing I do is I look at the ion and I figure out what it's called. I know that CrO4 is 8. 1 less oxygen, CrO3 is ite. Ite becomes us acid. So this becomes chromous acid. I could give you the name too, so I could give you something like, HBrO4. I look at this BrO4 and I know that it comes from BrO3, bromate. But it has one more oxygen, so it would be perbromate. Perbromate would give me perbromic acid. Now again, we're going to practice a lot of this in school. Hopefully at this point you sort of have seen, wow, I got to know these ions because this guy's going to be changing stuff up. He's going to have like an 8, he's going to make it an ite, then he's going to make it an acid, so I have to know how to do this. A little fun way to remember the acid names, it sounds like kind of a disease, adic, itis. So 8 becomes ic, acid, ite becomes us, acid, 8 ic itis. Thought that's kind of cool to think about. Alright, so this is all the naming, this is all that I'm going to do for this chapter. It's now up to you to learn the polyatomic ions and practice, and more practice. Thanks for watching.